Welcome everybody. Should be an interesting night. We've got quite a few strangers here who won't be strangers after a couple of minutes, because you're going to tell us who you are, where you're from, and also how you heard about tonight. Might sound like a silly question, but we do like to know. But before we do, something you might be interested in. You might have heard in our net the other night that I spoke about rejuvenating tired SLA batteries. Anyone hear that? Okay. Since then it's moved on a little bit, and I got this idea off a YouTube video that someone posted about rejuvenating tired SLA batteries. You cut the top plate off the top of the battery, and to do that you run a razor blade between the side panel around the edge, put a screwdriver on it, flip it off, and you'll see some rubber caps. Take them off, it's just like any other lead acid battery. He said the reason they get tired is because they dry out. And he just put rainwater in his, I put distilled water in mine, and I didn't even know there was a battery in this thing. It had been sitting there I don't know how long before I got it, and I've had it at least 3 years. And it's got a charger in this thing, turned it on, and it came up to about 7 volts. It's a 12-volt battery. So I did this half a dozen times, and it came up to about 8, and as soon as you turn the charger off, it goes down the tube again. So, and then I found this thing, so here's a go. Tried it, and now when I take the charger off, it's sitting at about 12.3. And I don't think I've got enough water in the cells at the moment. So if you've got some tired lead acid batteries, what do you got to lose? The cost of some water. Okay, just thought I'd mention that. Now, as I say, we've got some strangers, so you're not going to get away as a stranger. So starting at the front here, if you'd like to just stand up and tell us who you are, where you're from, and how you heard about tonight.
Jim Kirkhope from Woodend. My call sign is VK3KA. And our club got an email from your club telling us about tonight. So Graham, colleague, was kind enough to offer me a lift. So I thought we'll come up and hear what it's all about and meet you guys. So thank you very much for inviting us.
Thanks, Jim. On down, we have yet another ex-Dalian.
Yeah, my name's Paul Mellon from Caxdale, BK3. I heard about it. I was down in Woodend last weekend talking to Peter TQ and heard about it from him.
Thanks, Paul. We have Graham from Macedon. Might just tell us.
Yeah, Graham, VK3LA, and as Jim said, Graham sent me the email, so I put it out in the club here. So we hope to be all come along, but anyway, the 2 of us here, so the 3 are looking after the grandson. So thanks very much for the invite.
Thanks, Graham. And beside Graham?
Ray Sedgman, call signs VK3SED. I'm from Geelong Radio and Electronics Society with John here, and we received an email through our system. John, you can tell them about the email.
Yep.
Thank you, Ray.
John Forrest from Geelong Radio and Electronics Society. I'm the secretary, so I actually received an email. I'm not sure who it was from, so I just forwarded it to all the members.
Thank you.
So thanks for that. And actually, Ray and me come from Hoppers Crossing, Geelong, Hoppers Crossing, wherever. So we go down that way to the club. Thanks for inviting us.
Thanks, John and Ray.
Sorry, that does. Can I call sign?
Sorry, I didn't.
Did I say my call sign?
You most certainly can.
3K3JNF, sorry.
Oh, I think you did now. And sitting beside John is Ron, who was actually here on our Trash and Treasure night, but he arrived midstream and no one got a chance to meet him. Some of us did, but if you'd like to stand up, Ron.
Ron Duncan, Casamani. Yeah, I heard about the club and popped up last meeting, coffee club last weekend and so on, and ex-VK4 NRD, ex-VK3 NRD, and I've got a new licence application in Queensland, Canberra now, awaiting to be renewed. Thank you.
Thanks, Ron. And Dallas, Donna down there.
Dallas here, VK3, moved to Shep in the last couple of months. Heard about it through reading the WA news last week. Sort of followed the POA efforts and my method VK3ZAP from the Yarra Valley. Heard through the club rooms there. The Yarra Valley Amateur Radio Group, and just thought I'd come up and see what it's all about.
Okay, thank you very much. Down the back corner, or are you just keeping...
He's the grandson.
Grandson, that's right. You're keeping Grandad company, are you?
Yeah, that's Callum.
Yeah. Callum.
Callum.
Welcome, Callum. But don't just sit in the corner, you can join in if you want. And that's about all the introductions. And please, when we have a cup of coffee, don't let them stand in the corner on their own. Please engage them. Now, I bet some of you thought we were going to have a party tonight with party balloons.
One question.
Sorry?
Is anybody not happy with the photo being taken and put in our newsletter and our Facebook page? Is that okay? Okay.
Similarly, I might want to, when we're showing the videos, might want to show a little bit of video, like only 10-15 seconds.
Yeah.
What do you call that?
Yeah.
Don't focus too hard on any of us, you might break the bloody lens.
No worries. Sorry.
They'll call that creative editing. Shows up. Okay, thank you very much. Well, I'm sure you'll enjoy tonight. And Peter is part of who hasn't seen on the internet Analogic TV? Oh, I'll bet that surprised you. Worth having a look, and I'm sure you'll put the URL up somewhere where people can look at it. You'll learn all sorts of things, and you'll see this guy in pretty well every episode. He's one of the three musketeers that run that show. Better than playing solitaire and things like that. So now introduce you to Peter Barrett. Thank you.
Well, thank you very much, and to those that have travelled considerable distances to be here tonight, special thanks. You're very lucky that I'm actually even here in one piece. I've actually had 3 operations in the past week and a half, and so if I grimace a little bit, there's still a little bit of pain, unfortunately, but one more operation to go on Tuesday, and hopefully everything will be fine thereafter. Now, amateur radio on party balls. I forget whether it was Kevin or yourself, Graham, that invited me up here, but you'd seen one of my segments in Analogic, and I had been sort of still working on the project, but this has encouraged me to bring it forward a little bit. So we're not quite finished, but I think you're going to get a bit of benefit out of seeing where I started from, and where I've gone to, and the problems I ran into along the way. Also, you'll learn a little bit about Arduino if you don't already know about that. Great little microcontroller, really good for making in some really interesting projects. So, anyway, for those of you that don't know me, my name is Peter Barrett, and I'm licensed as VK3PB, which is the full call, and I'm located in Buang in the east of Melbourne. In my day job, I'm an accountant, and for the last 10 years I've given some of my spare time to help initially 3, but now 2 radio amateurs in Mississippi make a vidcast called Analogic. What's a vidcast, you ask? Well, it's basically a TV show that you download off the internet. You can watch it at YouTube or just download it directly from our website. For all intents and purposes, it's a TV show. And we've been doing that now for 10 years. We've made about 80 episodes. We put out an episode once a month on or about the 15th, and it's totally free, so you don't have to pay anything for it. Obviously, if you've got broadband internet, it's a little bit easier to download. We cover amateur radio, technology, and computing, and a little bit of photography as well. Now, let's see here. Now, what I really like to stress is that you're totally free to make copies of our programs in their entirety for any non-commercial purpose. The reason I raise this is because I'm sure that there are some radio amateurs here tonight who would like to watch our episodes, but aren't so computer savvy. So I encourage club members to burn some copies of our shows to DVD, so that club members can watch the shows on their DVD player at home. You might even consider putting a DVD library of material together if you use it this way, because there's lots of interesting material available to download on the internet. Now, I've been asked to speak tonight about a Picoballooning project I've been working on. At this stage, I'm very close to having a working model ready to fly. In fact, I literally got the parts, received the parts the last day or two. So when I fly the balloons in a few months, we'll be covering a segment on amatologic. But we're going to talk a bit tonight about my initial hardware design and how I came to get to the point that I'm at now. Now, what was the inspiration for all this? Well, it was in fact another amateur radio operator called Andy TK3YT, who is down in Williamstown. And I got an email or a bulletin, I'm not quite sure, and he was mentioning that, hey, I'm launching a balloon, can I have some help tracking it? And a number of people have been following along as Andy launches these Pico balloons, and they fly most of the time up and over Sydney, and there are various mechanisms to track the balloon as it's going along. So what's a Pico balloon? Well, you've probably heard about the big balloons that some amateur radio clubs have put together. I'm talking about big balloons with fairly heavy payload. They require CASA approval, that's Civil Aviation Safety Authority, the people that do government body that regulates airspace. And they're great projects and have great functionality. But they do cost a bit, and you've got to go and get permission to actually go and fly a balloon. A Pico balloon project is a lot simpler and a lot cheaper. So it's simply a big party balloon, that's so big, with a silver vacuum. You fill them up with helium and launch them into the sky with a small payload underneath. What makes it interesting from our perspective as radio amateurs is that you can add a GPS, a small computer and a small radio transmitter so that the balloon can periodically transmit its location as it flies through the air. What typically happens is the balloon goes up in the air, gets some kind of wind stream, and then scoots along at 100 miles an hour in a given direction. Andy has now made over 45 Pico balloon projects, flights I should say, and some have even been tracked all the way around the world, and one I believe even went around the world twice. So that's pretty incredible. Those latest balloons, the ones that went around the world twice, they, I believe, were solar powered. Something I've yet to investigate. Now, Andy's balloon transmitters are highly optimised to reduce weight. You've got to actually have a weight requirement for these balloons, and his designs are quite efficient. My approach to my Pico balloon project, as you see, is a little bit different. The attraction of a Pico balloon is that it's much cheaper and, as we'll see, and it's an easier project to build and fly than the big helium balloon projects that some clubs have tried in the past. Meeting the weight requirements of a Pico balloon project also poses certain challenges which are fun to try and meet. So, so if you just want to go to slide 2. Okay, this is Andy's balloon. Started off here, has flown, this is one of his more recent balloons, started off here, has flown around the world, and ended up back over Australia, which I think is quite an accomplishment. And that news was reported all around the world. We're talking about just a little party balloon with a payload of less than 50 grams, which is pretty incredible. And go to the next slide, please, Graham. And I was talking about a Pico balloon. That's one right there. As you see, there's its little payload just down below. Typically, you put a little phone house, something really quite light to house the electronics. Apart from that, though, balloon, helium, payload. Pretty simple, really. Now, next slide, please. Legislative issues. Okay, you've got to have some rules about launching stuff into the sky because, well, there's jet aircraft and light planes and other things up there, and you don't want anything bad happening. So what are the rules? Well, I'll direct you to an article by Robert Brand, and I'll just digress for a second here. Brand has been kind enough to print out a number of leaflets with references that you're all welcome to come and take a copy of. It's a single page. It'll give you a whole lot of references and web pages and things, including, I think, Amidologic is mentioned in there as well, where all the stuff that I talk about tonight, you can go and find further information. And Robert Brown's article I found really good because he covered the legislative side of picoballooning quite well. As Robert states in his article, in Australia there are 4 classes of free balloons, right? That's one you just let off up in the air. They are, next slide please, they are small, medium and heavy. Our interest is in the small ones. Now, next slide please. Now, CAR Part 101E, which is Civil Aviation Safety Regulations, Part 101E, states a small balloon means a free balloon that can carry no more than 50 grams of payload. If payload is less than 50 grams, no hazard approval, Civil Aviation Safety Authority, I think, approval is required to fly. And that's good because it means less paperwork and hopefully less cost as well. So that means that Andy's balloons, which are all less than, the payload is less than 50 grams, they're all classified as small balloons. Now, next slide please.
Just before you go on, Peter, can you give us an idea as to something that represents 50 grams? It's probably just a figure.
A good question. I would say a pinch, this Arduino Uno, would be around about 50 grams. So, you know, not terribly heavy. And so that's why you've got a weight requirement. You've got to have your battery, your computer, your GPS, all the electronics, and wiring everything less than 50 grams. It's a bit of a challenge, not impossible though. If you do your own circuit board, you'll get an even more efficient design. Because what you find is the less weight that goes into the actual circuits means more weight you can devote to the battery, which means that your transmitter will last longer. So it's, how do I put it, it's a question of optimising the design to get the best result at the end of the day. So, let's talk, another requirement is that provided he does not launch within 6 nautical miles of an airport, which is 11.112 kilometres, a single small balloon does not need hazard approval. So it's another requirement. Don't launch within 6 nautical miles of an airport, and arguably it's a good idea not to, you know, I wouldn't do it within 20 miles of an airport. It's given as much, and it might be a good idea to check out flight paths or where jet aircraft normally fly and try to, make sure your balloon is launched somewhere away from that. There are also prediction tools on the internet where you can actually put in the details of where you're going to launch from and on what date, and it can actually predict where the balloon is likely to go. So that's another useful tool that you can use. So here we go. CASA are the Australian Civil Aviation Authority, and their job is to police the Civil Aviation Safety Regulations, or CASA. Up to 100 small balloons may be released at the same time if far enough away from an airport or airfield without needing CASA approval. If more are to be released, the number and distance from the field must be considered as it defines what approval CASA needs to give. Most of the time, if you're doing your own project, you're only going to launch probably one balloon, so all you need to worry about is making sure that you're a good distance away from an airport and that it's less than a 50-gram payload. Other countries mostly have the same regulations, but you need to check before releasing any balloon. Everybody here is from Australia, of course, so in our case, we'll just follow the CASA guidelines, or regulations, I should say. I should say though, we're filming tonight for a YouTube video, so there'll be people overseas who might be interested in doing a bit of picoballooning, so they're going to need to check with their local aviation authorities and their own rules and regulations and see what's permitted and what's not permitted. Now, those were all Robert's comments. So next slide, please. To Robert's comments, I would add that you also need a durable identification plate. Now, that doesn't need to be particularly heavy, but it just means that when this thing is up in the air, that, you know, it's not just a piece of paper that could get blown away, something that's going to last, so that if the balloon lands somewhere, you know, and somebody picks it up, they know where the balloon came from. So even a small plate, or it doesn't have to be metal, a little bit of plastic, a little bit of paper inside it, just so it's saying, you know, if this is found, contact Peterborough and such a phone number. Now, the next one, please, next slide. Number 9, NOTAMs, or Notice to Airmen. These are, let's see here. Whilst it's not a legal requirement, I think it's a good idea to file a NOTAM, Notice to Airmen, with CASA, which is a notice to airmen letting them know where and when you're releasing your balloon. This gives prior notice to aircraft and other users of airspace that there's a free floating balloon in the area that they should try and avoid or keep an eye out for. As it says here, a notice to airmen, NOTAM, is a notice filed with an aviation authority to alert aircraft pilots of potential hazards along a flight route or at a location that could affect the safety of the flight. You're not legally required, as far as I understand, to file a NOTAM for a small balloon, but you're not prevented from doing so. So I think it's a good idea to do so, just so that people have situational awareness of your balloon flight. So at this point, you know, I learned about Andy's balloon flight, and I thought, well, I wouldn't mind doing one of these myself. But where I differed a little bit with Andy was he was actually designing his own circuit boards using some unusual microprocessors. I wanted to use off-the-shelf components like you could buy through eBay, and and also use libraries of software that were readily available off the internet. So that's why I've chosen to use an Arduino. So number 10, or sorry, next slide please, right? So I thought I'll build and fly my own Picoballooning project and film it for a segment for analogy. Where I differ from Andy though is that I want to make my Picoballoon as cheap as possible and to use an Arduino as the flight computer because it's small, light, cheap, and it's a microcontroller that I'm interested in. Now, for any of you who've never seen an Arduino, that's an Arduino. It's an Italian design, and let's see here. And these things cost less than, you can get a clone. It's open source hardware, it costs you less than $10. It's basically a small little programmable computer, and you can hook up various boards to it to make it add a GPS or measure things. So it's a really good prototyping tool. So let's now go through the components you need to build a Picoballoon project. First is you need a Picoballoon or similar party balloon, some kind of microcontroller, which you might use as an Arduino, a small GPS, and a direct digital synthesizer chip, because that's what your transmitter is going to be based upon. You're also going to need a battery and or a solar panel, and some kind of simple antenna, e.g. a short piece of wire, and a bit of helium as well. So in addition to this, you'll need a party balloon, some helium, some twine and string, and something light to hold the components in, like a little phone case. So the microcontroller I tested my software with was an Arduino Uno, and as I said, that's what I started with for testing purposes. Now, I wouldn't launch this up into the air. It weighs too much, okay? But there's a way around that problem. As I said, I'm going to use an Arduino. Now, okay, so there's the Arduino Uno. Now, these Arduino Unos are very cheap and popular. They are small computers based on an 18 Mega 328 microprocessor. They can be programmed in a variant of C, which is a computer language that can be learned with a bit of patience and time. The beauty of the Arduino, though, is that it has a huge community of maintenance support here, and many libraries of code that you can import in to do particular tasks. You want to add a GPS, you just download a GPS library, and that bit of code is all done for you. So it's really easy to add on extra components and get them to run. Let's see here. So if you want to transmit some Morse code, you just hunt around the internet, you'll find some code that will transmit Morse code, and you can just use this in your project. You don't Another good thing about Arduino is there's not just one type of Arduino. There are Arduino boards that are small and big with extra features or less features. Heavy Arduinos, and for this project, very small, light Arduinos. Now, as you'll see, the very first iteration of my project was built with one of these, an Arduino Uno. But the same code that I write to run on that will run on this. And this is an Arduino Pro Mini. Functionally, it will do much the same stuff as this. It will run the same code, but look how small it is. It's got much the same pinouts, and so I didn't need to alter the software at all. The only difference is that when you're using what we call the integrated development environment, which is just like a word processor, you just say that when you transfer your software onto the board using a USB cable, you say, look, I'm transmitting it or transferring it to a Pro Mini, not to an Arduino Uno. And yeah, very first time, no problems at all. So what I mean is that there's a much smaller lighter Arduino called the Arduino Pro Mini, which does the same things the Uno does, but it's tiny. It will run the same code though as the Uno. So the way one puts together a project like this is to first test and prototype using the Arduino Uno. And here is exactly what I'm talking about. There's an Arduino Uno. There's an AD9850 direct digital synthesizer, and there's a U-Blocks GPS. So initially I was going to have that and an Arduino Pro Mini for my project. And this is just exactly how you just get a couple of jumper leads, put it together, write up a bit of code, and prototype it, right? And then you just, for example, substitute the Pro Mini for this big board here. This is already a relatively light board. This is quite a light board. So hopefully at that point in time, you're well within your 50 grams limit, for want of a better word. So the way okay, so first test it with the Arduino Uno, and then go and substitute the Arduino Pro Mini and actually wire that and solder that in properly. So I'll get to our board as small as light as possible a little later, although I've already mentioned that 50 gram weight requirement limit. The GPS I chose was a cheap 9600 baud GPS board called the U-Blocks Neo 6M. And that's this thing right here. It's really two things. There's a little board there, and as you'll see, that's the actual antenna. So you need the two of the things together. From memory, I think it runs off 3.3 volts, as is this, and this can run off, I think, either 3.3 or 5 volts. You might want to, I need to double check that, but the setup I had in mind was all 3.3 volts from memory. So, where are we here? Yes, so cheap 9600 board, GPS board called the U-Blocks Neo 6M. Once you wire it up, it'll hunt around for satellites. One there, one there, one there, one there. It takes about 30 seconds from the cold boot, and then it will start, through those wires that it's connected to, it will start to spit out at 9600 baud all the GPS information, your latitude, your longitude, height above sea level, the accurate time, which is actually a really useful feature, and also the number of satellites that it's seen. All that information is just sent again and again and again and updated in real time. Move your GPS, the latitude and longitude will change. It's exactly the way the GPS works in your car or in your mobile phone. So, it's very easy to wire up. 4 wires. +5 or +3 volts, I think it was, 3.3 volts, ground, and then transmit and receive. Right. Now, there are also several software libraries available for use for the Arduino, and those libraries will strip out more or less information out of the stream of information that's constantly being sent out by the GPS, and it'll take those pieces of information, so the latitude, and put it into a variable for you so that you can use that in your code quite easily. Now, finally, the most interesting component of all was the direct digital synthesizer board. In this case, an AD9850, that little thing right there, which I showed you before, that requires probably 1, 2, 3, 4, 5, 6, 7 wires to be connected up to the Arduino Uno. When hooked up to a microcontroller using the right software libraries, you can generate a variety of digital transmissions on frequencies up to about 40 megs. So you can, for example, do read on 13.5 megs, and then immediately do a software change, make it do Morse code on 10 megs. It's a very, very versatile device, only limited by your imagination on the software that you're using. At a minimum, you can transmit Morse code reading and WSPR, but I'm sure other digital modes are possible as well. So let's now move on to my initial conceived idea, which was my transmitter. Actually, I'll just go back one step. Should we have the next slide, please? Okay, so that's the Arduino Pro Mini. Same functionality as an Arduino Uno, but less pins. But it's, I think, pin for pin, so you just wire it up the same way. Next slide. This is the U-Blox Nego 6M GPS board. That's the antenna, and that's the main board. Again, just 4 pins. VCC, that's +3 volt. 3 or 5, I think it's 3 volt. Ground, receive and transmit. Next slide, please. And this is the AD9850 direct digital synthesizer board. That's a lot bigger than it really is. It's a really small, light little board, and as I said, very, very versatile. So my transmitter version 1, my initial idea was to have the DBS, that's this board, transmit my call sign and my latitude and longitude via radio teletype at 50 baud. I figured that even though the power output would be low, the use of high HF frequencies, high frequency frequencies, and a narrowed down mode would mean the signal could be received a long way away. So let's now look at the segment I made earlier this year for analogic on my Ricky transmitter. It runs about 10 minutes and will show you what my setup looked like. Very similar to that, what you're seeing right now.
Hello everyone and welcome once again. It's spring here in Melbourne, which means that it's an ideal time of the year to get out and do some things. With that in mind, I've been working on a project. Now, if you've been looking at the Amatologic Facebook page, you'll have noticed that I've been working on a Picoballoon project. Now, what's a Picoballoon, you ask? Well, it's an exciting new area of the amateur radio hobby. Essentially, you take a party balloon, you know, the kind with the silver backing, and you attach a small payload of less than 50 grams. The payload typically consists of a small computer, a GPS, and a small radio transmitter, typically less than 100 milliwatts. And the transmitter typically transmits on amateur radio frequencies. Now, the idea is you release the balloon up into the sky, it floats up to about 8 kilometres high, and then is blown along by the wind. Every 3 to 6 minutes, periodically, it transmits its GPS coordinates as an encoded signal, either using APRS or RTTY or some other form of encoding. And you receive that back at your home base, and thus you can actually track where the balloon is going over time. Now, about every, say, 2 weeks or so, I get an email from a colleague here in Melbourne, Andy VK3YT, and typically that email says, "Oh, I'm releasing a new Pico balloon this weekend." And I and a number of other amateurs are able to actually track the progress of the balloon as it floats up in whichever direction it's going that particular weekend. Now, Andy's balloons have travelled considerable distances. Some have floated all the way over to New Zealand, and one even made it all the way over to Brazil. It must have wanted to have gone to the World Cup soccer, I figure. Anyway, with that in mind, I thought, why should Andy have all the fun? So I've decided to put together my own Pico balloon project. So let's now have a look at the hardware that I put together. My first bit of hardware is a tiny single board computer which was designed in Italy. It's called the Arduino Pro Mini, and you can pick these boards up online very, very cheaply. There are the originals which are available from Italy, and there are some clones that are available at much cheaper cost. This here is a programming cable with a small programming board, and you connect this to your standalone computer. What happens is you use this cable to send a finished program down to your Arduino, then you remove the cable and apply some power, and the Arduino will start to run the program. It's programmed in a variant of C. Now, the program which I put together using a couple of different libraries which are available online utilizes these two boards. This board here is a small GPS board with a little active antenna on top. It's a Skylab SKM53. When running, it listens out for GPS satellites, and it can work out what its latitude and longitude and height above sea level is. This information is periodically sent along these wires at 9600 bits per second. That information is received by the Arduino, and then the Arduino packages that up with a little bit of text and then utilizes this board to send the text as radio teletype. This board here is the AD9850 direct digital synthesizer. Amazingly, this tiny little board is capable of generating a radio signal from anywhere from 0 through to about 40 megs. What happens is, with a little bit of programming, the Arduino can actually generate, using this board, a radio teletype signal. And that's exactly what happens here. The GPS data and some other text is encoded as radio teletype and then periodically transmitted out on 13.600 megahertz in the 22 meter band. So let's hook up some power and we'll give you a little bit of a demo. The program that I use to decode the radio teletype is called MixW. It's shareware and it comes from the Ukraine. It's capable of decoding a wide range of digital modes. To use it, all you've got to do is hook up a cable from the audio output of your radio receiver and then run that to the microphone socket on your sound card. You then select the particular mode that you want to use and the program does the rest. So what remains to be done on this project? I simply need to install two simple transistors connected to two digital outputs on the Arduino and modify the software to turn the AD9850 and perhaps the GPS off when they're not being used. This will enable me to conserve power and allow 2 lithium AAA batteries to last much longer. I've already included a sleep library in the software, and I can put the Arduino to sleep for extended periods of time in order to conserve power further. You are probably wondering why I chose to use the frequency 13.600 MHz and what band this is in. If you guess that it's not a ham band, you're quite right. Here in Australia, the ACMA, our government regulator, has set aside a number of frequencies for low power use, and provided you abide by conditions in the rules, you can use these frequencies without any kind of license. For example, I can transmit up to 100 milliwatts in the frequency range 13.553 to 13.567 MHz, although particular care must be shown not to transmit in specified astronomy-related zones. The low-power frequencies are used for a wide range of purposes, including garage door openers, wireless microphones, and auditory assistance transmitters. Amateurs will be shocked to learn that one of the frequency bands specified is 3.5 to 3.7 MHz. Yes, that's right, the 80-metre amateur band. However, the maximum transmitter power permitted is just 30 picowatts. You can find details of the frequencies permitted and conditions of use in the Radio Communications Low Interference Potential Devices, or LIPD, Class License 2000, which is available on the ACMA website. I'm sure other countries have equivalent legislative rules and regulations. To finish this segment, a note of caution. Before undertaking any balloon project, you should consult your government's regulator of controlled airspace and clear what you propose to do with them first. As Crazy Russian Hacker says, safety is #1 priority. Equally, it's a good idea to check with your country's radio communications government authority before using any lower power frequencies in order that you are fully compliant with your country's rules and regulations.
Okay, so, but you'll notice a few little differences there. I actually used a different GPS for this prototype. I was using RIDI for my prototype. Now, can I have the next slide, please? Right, and you also note that I used 13 megs, which is the ISM band, industrial, scientific, medical. It's a little less restrictive than amateur radio requirements, and actually ideal when you use it. So these frequencies are free to use, provided you use the very low power that is specified in the regulations. So my transmitter worked. What you saw there before was my transmitter on my desk, transmitting about that far, right? But then I ran into a problem. I took my transmitter outside, hooked it up to an antenna, and left it running in my front yard. Now remember, I live in Baronia, which is a stone's throw from Mount Dandenong. I then drove up to the top of Mount Dandenong, which is 3 miles away, line of sight, and then tried to receive the signal. I could only barely receive the signal. So it became apparent that over longer distances, my balloon project just wasn't going to work. I needed a setup that could send a signal that I could receive when the balloon was hundreds of miles away and or far out to sea. So why didn't my RIDI transmission work? Why was it received so poorly? And I'll take answers from the audience. Anybody want to have a guess why it didn't work?
Not good enough.
Well, yeah. On the right track, 13 megahertz is, let me think here, 23 metre band.
So it's practical to have an efficient antenna?
Yeah, getting an efficient antenna on that frequency. Now, the antenna I was using, by the way, was untuned, so very bad SWR. But the point is that it's a very long wavelength, and so you're always going to have some degree of inefficiency because of that. That's not really a solvable problem other than maybe with a little bit of tuning. You can optimise it to match it as best you can. Let's say a piece of wire to match that to the transmitter. So anyway, the first reason has to do with the choice of direct digital synthesizer. The AD9850, I'm told, puts out about 1 milliwatt of power, which is not a lot. Clearly I need a DDS that will put out a bit more power or use some kind of power amplifier. The second reason relates to the frequency being used. I was transmitting on 13 megs, which is a good all-round band. However, the wavelength is about 23 metres, and the antenna I have been using was short and not tuned to that frequency. I can't really change the frequency much because I want to use the ionosphere. However, I can at least try and tune the very short antenna I will be using on the balloon as best I could so that there's no power loss to your poor SWR. The third reason relates to the mode used. RIGI is a good digital mode for long-distance transmission of data, but if you have a very small number of characters to send, the gold standard is WSPR, WSPR, which was a very recent digital transmission medium put together by, I forget the guy's name, but he's a physics professor.
Joe Taylor.
So Joe Taylor, is it?
Joe Taylor.
Thanks for that. Yeah, Joe, K1JT. And, you know, even with a comparatively small amount of power, because of the digital techniques used at the reception end, you can dig the signal right out of the noise. And so 10 milliwatts will get you hundreds of miles. It's really, really a very impressive thing. So, take a next slide, please. So, best long distance mode for very low power, WSPR by K1JT. It has its limitations. You can't transmit more than 13 characters, and that's done over a 2-minute cycle. But it can be received really long distances. So, now, next slide, please. So, since making that first video, I've been researching version 2 of my balloon transmitter to deal with some of these problems. And my proposed version 2, as I planned or thought it might be, would again use the Arduino Pro Mini, same direct digital synthesizer, same actually different GPS to what I used before, which is previously I used a Skylab, now I've changed to the U-Box. But this time I would run WSPR on a single frequency. Now, because of the 13 character limitation, I couldn't transmit the full latitude and longitude. I would require too many characters. But there's an easy fix for that, and that is to use a Maidenhead grid square locator. It's a 6-digit character that will give you an approximation of your location for 3 miles. Basically chops the world up into a series of grid squares, and 6 digits tell you which grid square in the world it is. So for example, my home grid square in Buang is QF22PD, and so that's basically the northeast part of Buang. Let's see. Okay. Next slide, please. Right. Okay. So anyway, version 2 would be made in the same hardware as version 1, but instead of transmitting GPS location via RIGI, I now use WSPR. As you entered to transmit in 13 characters, I needed to condense my latitude and longitude down to a small number of characters. So I wrote then a C subroutine, that's a program within a program that would do that conversion for me. It would take the variables of latitude and longitude that I pulled out of the GPS, and it would determine what the Maidenhead grid square locator was. And before proceeding on to progress my Picoballooning project, I then had an idea for a spin-off project, which is what we're going to have a little quick look at now. It's called the VK3PD SOTA box. I've built this, tested it, used it, other people are building it now, and it's rather useful. It uses very similar hardware. Again, it uses an Arduino Uno. Now, I've got no weight requirements here, so I just use a full Arduino Uno. It uses that U-Box GPS that you saw before. A little LCD board that clips on to the Arduino Uno. I don't need to wire anything up, I just clip straight on the top, and a battery in a case, and a switch. When switched on, the Arduino pulls down the latitude and longitude from the GPS, converts this to a Maidenhead grid square locator, and displays the latitude and longitude, and then the grid square on the LCD. The rationale behind this is that if you ever do SOTA, which is Summits on the Air, you go up to some mountaintop, let's say, I don't know, Mount Ararat or wherever, and you typically will give your grid square locator when you're doing your voice communications. But how are you going to get your grid square locator? You might have to do the calculations and everything at home. So this makes it easy. You just flick the switch on, and lo and behold, the box tells you where you are and what your grid square locator is. So let's now look at the segment I made, another short segment, which shows the finished product. By the way, this illustrates how if you work on one project with Arduino and you write some code, you can reuse it in another project, which is rather good.
Number 77.
Yep, number 77.
Hello everyone and welcome once again. Well, I'm not at home today. In fact, I've come out here 40 miles due east of Melbourne to a place called Mount Donna, Buang. It's a mountaintop in a national park. And well, apart from coming out here to admire the scenery and be eaten alive by the Mozzies, why have I come here? Well, I've come out here to test an invention of mine called the VK3PB SOTA box. What's SOTA, you ask? SOTA stands for Summits on the Air, and it's basically when amateur radio operators go to a mountaintop somewhere and they work other amateur radio operators from that mountaintop, in the same way that you might go to a rare foreign country like North Korea and work other amateur radio operators from that location. Now, one thing you do when you come to a mountaintop like this is you need to be able to give people your location. Now, you can give them your latitude and longitude, and you can probably get that from the GPS on your mobile phone, but amateur radio operators tend to use a grid square system called the Maidenhead grid square. It divides the world up into 18 by 18, then that's subdivided into 10 by 10, which is in turn subdivided into 24 by 24. What you end up with is a little square, which is a couple of miles by a couple of miles, approximately, and it's 6 digits long. And so it describes a region, not a precise location, but it's really useful for giving people an idea about where you're located. So at home, for example, my grid locator is QF22PD. So, well, what's the purpose of this box then? Well, what the box does is it's got a GPS, an LCD and an Arduino inside of it. When I flick on the switch, the Arduino and the GPS will lock onto the satellites around me and determine the latitude and longitude where I'm located. It will also pull down the exact time in UTC. Finally, the Arduino, from the latitude and longitude that it's got, will then go on to calculate my Maidenhead grid square. Or at least that's the theory. I've never tried this away from home, so we're going to give it a try today. So let's give it a go. The moment of truth has arrived, but before I switch the box on, let me give you a heads up about the location of Mount Donna, Buang. I checked on Google Earth before I came here and found out that it's located at 37.706905 degrees south and 145.680826 degrees east. That calculates out to be a Maidenhead grid square locator of QF22UH. So let's switch the box on and see what it comes up with. Now initially you've got a nil latitude and a nil longitude. That's the default, and you'll get an invalid message for the UTC. The Maidenhead grid locator at this stage will be based on the latitude and longitude of nil and nil, but that will change. Now it's already locked onto the time, 0531. I should warn you that I've switched this on before and just warmed it up a little bit. From a cold start, it can actually take a couple of minutes to get going. but should be a little quicker now that it's had time to get started. And there we go. Now, I said I had or checked Google Earth and got a latitude of 37,706,905. Well, it's come up with a latitude of 37,707,118. That's because I'm a little bit away from the main tower here. And then going in the other direction, 145,680,826 versus 145,682,617. So that's within acceptable margins. Also, the Maidenhead grid locator, as I said, was QF22UH, and that's exactly what the box is telling me is the Maidenhead grid locator. How good is that? Time now for a closer look at the parts that make up the VK3 PB SOTA box. This is a standard Jiffy box, nothing particularly unusual about it. You can use any box you like. Here I've made up a little 9-volt connector through a switch and going into a female connector for the Arduino Uno. This is a cheap Chinese clone of an Arduino Uno, pretty stock standard, and of course I've got a USB cable for programming the Arduino Uno. Battery, of course. Now, this is a robot board, a little LCD board or LCD shield for the Arduino Uno. It just plugs into the top of the Arduino Uno like so. Now, one important thing to note here is that when you get the board, you'll have a little connector, or rather a little variable resistor, which is here, which is actually wired into the top of the board here. Problem is it protrudes upwards, and if you try to put this flush with your box, you're going to run into problems because it will interfere and get in the way, which is why I've wired some wires through to it and put it over here, and I just tape that to the back of the LCD board when once I've wired it all up. That way it's out of the way and I can actually put my LCD screen into the box. Over here I've got my U-Blox GPS receiver. This is the actual receiver, and this is the little antenna over here. You see I've stuck that with some glue onto the top of the box, and underneath here you'll see a little connector. I was finding that it was actually causing a little bit of interference and it wasn't working quite properly, so I put a little bit of silver paper which I've glued on the back here. That seems to have helped a little bit. You know, it's probably optional, but it seemed to help the operation and reception of the GPS receiver. The GPS receiver, by the way, has 4 connectors, and they are VCC, RX, TX and ground. What you do is you take 4 wires out of those, and then what you do is you connect ground to the second pin counting across to the left here. So 1, 2, that goes, so you've got ground going to ground on the little board there. VCC goes to this pin here, 1, 2, 3, 4, 5 across. Over here, this is looking at the underside of the board now. If I turn it this way, this pin here, and I'll see if I can count across here, 1, 2, 3, 4, 5, 6, 7. The seventh pin is pin 13, and the 6th pin is pin 12. Pin 13 goes to TX on this little board, and pin 12 goes to RX. And so that's basically how it's all wired up. And yeah, so basically it's a simple matter of connecting, or rather plugging the shield into the top of the Arduino, programming it with the software that I put together, and of course having it connected up to the receiver as I've specified, applying some power, and of course connecting the antenna up to the little receiver board here, and it should all work. So, so that's an interesting spin-off project that just illustrates how modular the whole Arduino ecosystem is, how you can use pretty much the same parts to do a whole lot of different things. Now, I have see the next slide, please. Okay, now next slide. Okay, so, anyway, if you think about my project, what I'm trying to now achieve, essentially, from a software perspective, my Arduino will first of all pull down the latitude and longitude, sort of have the software to do that from the GPS. It'll then have some code which will take the latitude and longitude and convert it into a Maidenhead grid locator. Well, courtesy of that project that I just built, I've now got that with the code. But there's one more piece of code that I did, and that was the ability to send those 13 characters out as a whisper signal, a WSPR signal. It had to be code that was specifically written for the Arduino. And really, the last few months, that's what I've been looking for, trying to find some code that would actually work with my hardware and actually transmit a whisper signal. Now, to cut a long story short, and you might go to the next. Okay, so can you go back one? Yeah, okay. So anyway, after much research, I finally stumbled across a chap called Gene W3PM. He's built a project very similar to that which I envisage. His project though was designed for larger balloons and also used slightly different components. The software transmits the Maidenhead grid locator as WSPR across multiple HF frequencies. So it'll go transmit on 10 megs, it'll flick over to 15 megs, then over to 20 megs. Quite a versatile bit of software. Now, Gene's hardware differs from mine in a few minor ways. Next slide, please. First of all, the Arduino used is an Arduino Uno. In his design, because he doesn't have, with his bigger balloons, the weight requirements aren't such a big deal. But I can easily use an Arduino Pro Mini for my purposes, so that's no problem. The direct digital synthesizer, though, used is an inexpensive Adafruit SI5351A clock generator breakout board, which will do from 8 kilohertz to 160 megahertz versus the 40 megahertz of the 18950. So this gives it a lot more versatility. I can probably push the transmission up into 6 meters and 2 meters now if I want to go up to those frequencies. And of course, if you're transmitting on 2 meters, well, much shorter antenna, you're going to have much more efficiency. But I'm still interested in transmitting on HF. This board is actually also relatively cheap, and I actually may as well show you what they look like. Where is it? Have I got one here? No, I think I did bring that board here. Just a second. My apologies, I've misplaced it, but I have another board which is a little bit about that size, which is the the SI board, the SI5351. Very small, very light, will transmit much the same way as the 18950, but of course it uses a different software library. But I've got the code from June, so that's not a problem. So here's hardware, Arduino Uno, the SI5351 clock generator board. He uses a 4800 bits per second US GlobalSat EM406A GPS, which is this thing. So I haven't taken it out of its packaging. Very similar to look at as the other GPS, but spits out at 4800 bits per second. The unfortunate thing about this particular board is it's a bit more expensive.
The other bits and pieces are all relatively cheap, you know, between $5 and $10. This is somewhere in the order of $40 to $50. So I'm hopeful that I might be able to convince Gene to modify his software to use a cheaper GPS. But for the purposes of my first balloon flight, I'm going to go with his hardware and use this. So let's see, next slide please. Oh, sorry, and by the way, he's also uses a liquid crystal display. Again, he doesn't have the weight requirements with these bigger balloons, so he can actually have an LCD there which is actually giving you details about what latitude and longitude is actually being received. You can actually visually see that. I can just disconnect that because I don't need it for my particular project. Next slide, please. Okay. The software that he's put together transmits the WSPR location, which is drawn from the GPS, and basically sends the call sign plus the Maidenhead grid square locator as calculated on a sequence of different HF frequencies. That SI board, the SI5351A, so Gene tells me, puts out 8 milliwatts versus the 1 milliwatts that the AD9850, which is good because it means I've got more power going out now, which means my signal will probably be it will be easier to receive, and with the added benefit of being WSPR, the chances are that I'll be able to transmit and receive my signal over a much longer distance. The direct digital synthesizer is a little bit cheaper. The GPS is a bit more expensive. But ideally at the end of the day, I'd like to get a design, a finished design for general usage, which uses a cheaper GPS. Next slide, please. Now, harmonics. When one slight flaw of these particular DDS boards is that they can often generate harmonics, and as you know, harmonics are not a good thing. So Gene advises me that the output is rich in harmonics, so some sort of low-pass filter will be necessary just to filter those out. A couple of capacitors will probably do that. I'll have to look in to see what I can get together. Another option is to use a small power amplifier, subject to the weight and power limits, of course. Obviously, if you have a small power amplifier built in, you're going to chew up more power, and your battery isn't going to last as long. So, you know, it's all a juggling act between various considerations. Good. Now, I should also mention I haven't discussed what antenna I will use. Likelihood is that I will use a small piece of light copper wire wrapped up and over the balloon. It'll either be tuned by cutting to length or with the use of a small tuned circuit. And that really just about wraps up the talk for today. Next slide, please. The points I want to emphasise are, first of all, Picoballooning is an affordable and interesting area of amateur radio that club members and or kids can get involved in. Ideally, an ideal project for a school where you build a small pico balloon, launch it up into the air, and the kids can actually track it in real time. They learn to use maps, and they get a little bit of an understanding about radio and what's going on. So that's good. The second point, and probably this is the most important point, is that safety is paramount, and you are responsible for your balloon and where it goes and what it does. So with that in mind, it's a good idea to talk to the Civil Aviation Safety Authority first about your project, check out what the current regulations are, just in case they've changed. A NOTAM is a very good idea, a notice to airmen, just letting people out there know that, hey, I'm launching a balloon in your district. And although I talked about using a lithium-ion battery previously, with bushfires in mind, it's probably not a good idea. It might be better off just using a more standard battery. Even you don't get quite the power density, but it's probably a bit safer. Okay. Now, so in my view, don't launch with any kind of flammable battery, e.g. lithium, particularly in bushfire season. And for launch well away, greater than 6 miles away from all airports, it's a legal requirement.
and you're legally responsible for your balloon, so build it robustly and in accordance with CASA regulations. Next slide, please. Okay, now I put together a summary leaflet, and Graham's been kind enough to print a number of these, and they provide a lot of links to a lot of the material that I've covered tonight, okay? So I don't profess to be an expert by any means in this area. I just really wanted to talk a little bit about what I've been doing and sort of how my project's been progressing. I'm now at the stage where I can actually build and fly the thing, and I'll hope to cover that on a future episode of Amateur Logic. Feel free to grab a summary leaflet. Do we have any questions? Does anybody?
Yeah.
Sure.
You go into a bit more detail on the area. You brushed over very loosely there. Is it something like draping over the balloon?
Well, it is silver. Okay, so I need to double check, but I think there is a requirement in there somewhere about how physically big your balloon can actually be. I need to go and double check the regulations. So the idea is I'm not really keen on the idea of having a long wire draping down below my balloon, because if it hits power poles, that could cause a few problems, you see. So, my sort of general plan, if I can do that, is using prediction software and selecting my site, is I want to launch well away from an airport and ideally launch into winds that are going to blow the thing out to sea as quickly as possible, so that it's well away from any landing on anybody's head or landing on any power lines or causing a bushfire or anything like that. It's really more a question of launch it out into, say, the Pacific Ocean, see how far it'll go and how far my signal can be received. Yep.
Couldn't you use a core helically wound?
Anything's possible. I haven't settled on a final design as yet.
Or a loop like that.
Yeah, remember they've got a weight requirement of 50. 50. But and keep in mind that that silver backing will affect the performance of the antenna. Probably a loop under the balloon might actually be better, because then you're going to get the radiation going out in all directions. So there's room for playing around and trying what's best. So.
The members that come here tonight on this road, do you have any control over the balloons or when they can land or anything like that?
In a word, no.
Well, I guess I probably answered the question before when you said if you send it out to sea, there's probably minimal chance of...
it's...
One of the questions was what happens if it lands on the road or
exactly.
a car or something like that. If you send it out to sea, then minimise it.
So, to go back to what I said before, remember, you're responsible for your balloon, so if something bad happens, it's going to come back to you. So there is always a risk, and you can't eliminate risk, but what you can do is you can minimise it. And you can minimise it by, first of all, launching a considerable distance away from an airport. Secondly, building your design robustly and in accordance with the regulations. And thirdly, using prediction software, which is available on the internet, to pick a day when the winds are blowing in a particular direction where it's going to go away from populated areas, it's going to go out to sea or, into some area of less risk, away from flight paths, whatever, okay? So ideally, you sort of plan your launch date to minimise your risk. Sorry, okay, Kevin.
Just thinking on that, and I was going to ask a question about something that's concerned me for some time. What's going to happen when one comes down in the middle of a busy freeway? But make sure it's going out to sea, that's the launch engine thing.
Mm-hmm.
That balloon that's gone around the Earth twice,
yes,
I would say not very long after it left his hands, he ceased to have any control over it whatsoever.
Correct.
And he's going to end up where it wants to end up. And you have no, unless you, through its telemetry, know where it's going to come down and you drive around with a rifle or something. So,
Some early iterations of Andy's balloons, right, transmitted on VHF through the APRS packet system, right? So basically, you could sit there and you could go to APRS.fi,
big world map, zoom in on Victoria, New South Wales, and watch the balloon moving in real time. Well, one day I sat there and watched one of these balloons, and it's working its way up the Hume Highway, and eventually came and crossed, admittedly at a decent height, across Sydney Airport. So I'm like, oh, that's interesting. But it kept on going, and there was no mishap. So
the thing is, to me, it's only virtually party balloons.
That's right.
The kids are letting party balloons go all the time.
Correct. And you'll
So what is the difference? Not much.
Theirs doesn't have a motor.
Yeah,
that's pretty much. So,
Getting back to the party balloon bit, the question I was going to ask is a fundamental one. You call them party balloons, you see them, sort of for sale on a stick anywhere. Are you talking about literally buying one of those, or is it a bit more sophisticated than that? If you put get helium from somewhere, wherever you get a bottle of helium, and load it up yourself, is there pros and cons about how much helium you put in a given size balloon?
There are a few considerations there from what I understand. My understanding is you can just go to your party balloon shop, for want of a better word. Buy a balloon. Yeah. Helium is also not cheap, but easily available. In terms of filling the balloon, the only consideration I understand is you don't fill up your balloon right up, because the balloon will expand as it goes up in the air. So that's something you do need to consider.
But that's the question I was going to ask. Why do these balloons seem to stabilise at about 9,000 metres, where latex balloons, where they've got the same strength, they'll go up to 40,000 and burst? But these things seem to balance at that.
I wouldn't know.
Atmospheric pressure against volume. Volume will allow it to go to a certain height in atmospheric pressure. For every 1,000 feet above 8,000 feet, pressure drops at 1.2 litres height to 1,000 feet. So somewhere in there it will find balance of displacement versus external atmosphere.
Now, there was one thing I didn't cover, which is also a consideration in your design or whatever you put together, right? When you go up 7-8 kilometres in the air, it gets real cold. So any of these components that you use need to be rated for like less than 0 degrees. So just keep that in mind when looking at your components and making sure that they'll actually work. And that includes the batteries as well. Some batteries may not work at low temperatures. So that's it.
With the, you mentioned the 13.5 megahertz frequency before. Do you know if anyone else used that frequency and what results they got from it?
No. So I just thought that it was, from a regulation point of view, a little bit easier to use, because you wouldn't have, for example, I think there's a requirement in the amateur radio regulations where you have to be able to remotely switch your transmitter off if it's causing interference. You probably wouldn't have that same requirement with an LIPD. So you can just avoid some of those problems that way.
Well, has Andy got that on his?
I believe he actually has some mechanism to actually switch it off, but his designs are a bit more complex and are custom made. So, but to the best of my knowledge, they're not freely available, so it's not like you just go buy them. There is I believe though, in my links here, I think there is a shop in England where a guy called Leo Bodmer, who runs an electronics store, he has some off-the-shelf type gear that you might potentially use if you're contemplating a balloon project. So
in any 24-hour period, what's the sort of transmit time? Are they equally periods of transmission?
Andy's balloons on 2 metres, I think were set to transmit somewhere around between 6 and 10 metres, 6 and 10 minutes apart. I think it varied a bit from balloon to balloon. So he was transmitting initially on 2 metres on the APRS frequency. There'd be a short burst of data, and then, we'd just go quiet for a number of minutes. And then when you actually looked at the plot on APRS.phi, you would see, right, received a packet there, received a packet there, and then the program would just join the dots, and you could see the flight track.
Roughly how long, what's the milliseconds to the length of the packet, transmission time?
From memory, from packet, the radio which I've done, I'm not sure the number of milliseconds, but it's a fraction of a second. It's not very long.
What about the quiescent, final question, what about the quiescent currents, very, very low?
Quiescent, meaning?
Like when it's in its quiet state, not transmitting.
Okay, what I plan to do with my design is I use a subroutine called narcolepsy, which is a C routine that's available on the internet. Okay, and what it does is it will actually put the Arduino to sleep at very, very low current usage, so you conserve power. I mentioned briefly using a couple of components to try to switch the AD9850 and the GPS off to conserve power as well. The trouble is, even though I was able to do that and switch the plus 5 volt, etc. off, because I had all these other lines, it kept consuming power. So I'll have to play around with that and see what I can do. But it's sorry, yep.
The balloon's radar reflective. Large plane with a radar.
I can't give an authoritative answer on that, but I think it is, just based on the design.
Do you know if Andy had proportional beaconing with his APRS, or was it just transmit every interval?
Proportional beaconing meaning?
I use APRS on the bike at times when I feel like it.
Yes.
Where you put in parameters that change the beaconing.
Oh, yeah.
Depending on the speed you're travelling and the angle of deviation.
He customised his software so that it's not so much based on speed, but where you are. So once it got out to sea, it actually would it would change the number of minutes that it actually transmitted apart. I mean, you'd need to double check this with Andy, but I'm going from memory. The other thing also was that it actually would change frequency if it went over New Zealand, because I think they use a different frequency. So he actually had some customised own settings for all of that, but it would not so much
increase its power output when it went over America.
Yeah, I don't know about that. Put it this way though, his balloons, none of them have gone up above the equator as far as I know. So yep.
I think the answer to your question about whether it's using smart beaconing, no, they wouldn't use that because you don't have a corner stuck in a balloon. So it is, from the ones I've seen, it's usually, I've thought about 5 minutes between his beacons and they're constant that it's already distant because it just didn't get any distance.
It might have been handy if it became like Youngster, just become something that's pretty well stationary and maybe it never gets stationary.
Yeah. Anyway, if I could just digress and tell you a little tale, there was another one of Andy's 2 metre balloons that he released from Williamstown not that long ago, and it floated up towards Wangaratta, and it came down on a farm, sort of the south, basically south of Wangaratta. And so Andy was in a chase car and drove up the Hume Highway, and he had his APRS tracker in his car as well, so we were tracking both the balloon and him, and texting him messages back and forth. And he got up there just before dusk, and we could see him, because he had a portable GPS tracker on him, physically traipsing across this farm where this was. And then it got dark and we didn't hear anything from him. We're going, what's going on here? An hour or two later, he finally got back to us. And what had happened was the balloon, he'd actually spoken with the local farmer, gotten permission to go in and have a look around, and he ended up having to cross a creek and the balloon had actually landed up in a tree, so he wasn't able to go and fetch it. But these are the pitfalls of free-ranging balloons. So, so depending on how far they go, you might actually have a chase car that goes. Another thing is also there's a bit of a community of people out there that are interested in this and that will help you track your balloon for you. So they'll listen in on a WSPR frequency or just there's actually like a chat forum, a real-time chat forum where they can discuss how a balloon is progressing as it's going along. And it's fun to just go onto that and chat with people in real time as you see the balloon passing over Canberra or whatever. And of course there's also things like APRS.fi and SpaceNear.us which will actually give you a real-time graphical map and location of where the balloons actually are at any one point in time and also where they've been. And if you click on the various points on that tracking map, which are the points where the packet was received, you'll get the details about when the packet was sent, what the latitude and longitude was at that point in time, the height above sea level of the balloon, the number of satellites it was receiving, and other details that are sent in the packet. So it's so you don't actually need to launch a balloon to actually participate. You can just follow along with one of Andy's balloons, and you learn a lot just by talking to people and getting an understanding of by actually participating in that way. As I said though, my designs differ a bit from Andy's in that I'm really working towards an off-the-shelf solution, stuff you can just buy easily on eBay, and Arduino based, and he uses I think different microcontrollers to what I do.
Do you have any use of packaging and forwarding with the people who launched those Horus balloons in South Australia?
I did get in contact with them. Okay, in fact, I even donated some bit of equipment to them at one point in time. But after I donated that bit of equipment, they never responded to my emails. So I don't know whether I said something that upset them or whatever, but yeah, I don't know. But they've been launching some big balloons over in Adelaide or around that area, and it's been fun to watch what they've been doing because they have chase cars that run across to Renmark, Loxton, that kind of. The balloons have gone out to those kind of areas and they've tracked them. But again, those are big balloons. They've got to get CASA approval and everything, and that's going to involve some extra cost as well. Whereas what Andy's doing is actually much more affordable, and you can do one every second weekend and at a reasonable cost.
But they can put video cameras on there, so you can't on yours.
That's true, okay, although I believe one of Andy's Pico balloons, he actually put a camera on there and was able to transmit some stills back. So
there's no legal issues like as far as ACMA is concerned with transmitting a call sign and not being able to turn a transmitter off and that sort of thing? Or?
Well, again, I think there are some requirements around that, like possibly needing to be able to switch it off remotely if you're causing interference. But that's why I sort of proposed to go the LIPD route, because the rules are a little less strict, and the frequencies that you use, the power designated is much, much lower, and it's within the same kind of power range that we're talking about with these little DDS boards.
And what if you flew over another country and the band you were transmitting was like out of band for their requirements? Like, what is that something you have to take into account if you do planning? Or
theoretically,
one even know where it's going to...
The short answer is I don't know. But if you have a GPS on board and a microcontroller, you could probably program it to either not transmit in certain geographical regions or transmit on a different frequency. So, those problems can be solved in software. Okay. Okay, well, again, thank you very much for inviting me up here. I'm sorry I sort of don't have a complete design for you at this point in time, but I am literally 95% of the way there. I've got my hardware, I've got the software that June W3PM has given me. I'm told once I wire it up, will work out of the box. All I'll need to do then is to just put in some routines like narcolepsy to actually reduce the power requirements, hook up a battery, and then go fly. So hopefully in the near future we'll actually have a bit of a segment to actually show you. The other thing, by the way, just as an aside that I want to mention, this year is the 10th anniversary of Amatologic, and you know, whilst we've produced 80 odd videos, I've actually never met the guys. They're all over in Mississippi. They haven't been down here. I haven't been over there. Now, on the 13th of August, touch wood, unless my health falls apart, which it could do any day, I'm going on a round the world trip. So I'm actually going to go to the Huntsville Hamfest, and in the next episode of Amatologic, you're going to see all three of us together for the first time, which should be quite a worthwhile episode to watch. And we'll have coverage also of the Huntsville Hamfest, and that's always, from what I understand, quite an interesting. It's a big ham fest with lots of people coming from all over America, if not internationally. Should be lots of interesting interviews and coverage of all the things that are going on there. Anyway, thank you again for inviting me up here, and thanks Kevin, thanks Graham for helping out, and best of luck with your project. Thank you.
If I might, what happened to the fourth guy? A couple of years ago, he sort of went south or something.
Yeah, we started with three guys, George, Tommy and Jimmy, right? Jimmy Burrell. And for reasons best known to him, he decided to give it away after a period of time. And so that just left the three of us, and we've sort of continued on for another 40 or 50 episodes thereafter. So, look, we've had Jim come back on from time to time. He's absolutely always welcome. He's a great guy, and I hope to actually also possibly see him in Huntsville as well. So,
used to look forward to listening to his accent.
Look, to be honest, some people used to make a bit of fun of his accent, and he might have taken that personally, but as I said, he's a great guy. He was very, very popular with all the viewers, and he put together some really, really good segments. So, I hope that we see some participation from him in the near future. Okay? Yeah, thanks, Kevin.
Thank you very much. That's a token of our thanks.
Yep.
We'll take this one home.
Okay, well, thank you very much. I'm not a drinker, to be honest, but I will use his in my cooking, so...
You probably want to take a photograph.
Okay. Okay. Thanks, Kevin.
Thank you.
Thanks, everybody. Thanks, Brian. By the way, my email address is at the bottom. If you have any further queries, out of session, feel free to give me an email. I don't claim to be an expert in this area, but often I can point you to a resource that will answer your questions. So thank you. Good. So did that work, do you think?